We have a buzzer here. Buzzer SFM 27-11 Chinese. The supply is 3 to 24 volts DC. The other one also buzzer, same specs. Let us test the buzzer. We're going to use this 18650 battery. Since this is 3 to 24 volts and the voltage rating of 18650 is 3.7 up to 4.2 volts. So let us test. We can hear the buzzer sound. So the sound is intermittent. The other buzzer, same model. The same sound, intermittent. We have a new buzzer. Let us check this new buzzer from Detector, the first electronics supermarket in the Philippines. It cost me 50 pesos, $1 US. It is buzzer 3 to 24 volts continuous. Why is it continuous? What's the difference between continuous and intermittent? DC 3 to 24 volts, SFM 27-1. Here it's dash 11 or 11. That's the difference. And the Chinese, I don't understand Chinese. So let us check this. Okay. So this is continuous, while these two are intermittent. We are using this module. This is infrared proximity sensor. So it is a kit or a module with two infrared LED. One is transmitter, the other is receiver. And then the IC used is an op-amps LM393 comparator, also to adjust the sensitivity with onboard SMD components and two LEDs for the onboard power and then for the output LED. We have 3 pins, BCC ground out. BCC ground out. BCC ground out. This is we can use a supply of 5 volts for this module. What are we going to do? We're going to make a fire alarm using this module. And we're going to connect this into our breadboard. To the breadboard with the buzzer. Of course, we need the supply. We're going to use this power bank with cable. That is powering on the circuit without a biscuit. So you can see here the power LED of the infrared proximity sensor turns on. And we're going to use this lighter. Since we're going to make a fire alarm, let us check. So you can see there, the output LED turns on and the buzzer turns on. So it detects a fire at a distance of around I think 6 inches. So we have now the fire alarm using infrared proximity sensor. This is the actual. We have the module BCC ground out. This is the module IR proximity sensor. BCC is connected to the power supply. What is this? Power bank. And then the positive. The positive of the buzzer, which is the red, is connected to the plus voltage supply. And then the negative is connected to the out. So there is also ground connected to the ground supply to the BCC. we have two LED. One is the power LED. Whenever we connect the power supply, this LED turns on. And this is the output LED for this out. As you can see here, this is out, but the connection of the buzzer is positive to the 5 volts and negative to the out. So, and we have two infrared LEDs. The white and the black color, the transparent type. The transparent type is the transmitter. So if there is no any fire hazards or fire, for example, we have this lighter and fire. Once it detects a fire, the signal is bouncing back to the receiver, this receiver infrared LED. So if there's no fire, it cannot detect anything. Once there is a fire, it will detect the fire, and then because it transmit infrared lights. So it transmit infrared lights to the lighter and bouncing back to the receiver, now being received by the module. This LED turns on. So this LED turns on. And what happened is, instead that the buzzer is connected to the positive to the out and then negative to the ground, it is connected the positive to the 5 volts and negative to the out. So once it detects a fire, it turns on the LED, and this output will now become an input in, because once it turns on, current flows into the positive to the negative of the buzzer, and it flows inside the module. So it will now turn on the buzzer. I chose to connect this buzzer in this way because I want the LED onboard out LED and the buzzer to be on at the same time. So whenever it did not detect any object or a fire, this out is high level. It means there is a current that flows into the circuit. Why? Because it continuously transmitting these infrared lights, and since it did not there's no fire, did not detect any fire, the output is high. There's a current that flows in. So when the output onboard LED has no light, turns off, the out is high. There's a current that flows here, causing the buzzer not to turn on. But when it detects the fire, it will turn on, and this out becomes low or almost to the ground, pulling it low to the ground. So the current now flows into the positive of the buzzer, negative, then flowing inside this module. We call that a sourcing current. So this out could be an out and sometimes an in. Okay? Why? Because of this inside this op amps. There is an op amps here. Also, we have this sensitivity. When you use this sensitivity range, you can increase or decrease the distance between the fire and the module for the detection of the fire by adjusting the sensitivity range. So that is the connection of the buzzer. Positive to the 5 volts, negative to the out. It becomes now in. It turns on the LED and turns on the buzzer once it detects any fire. And normally it turns off. Initially it turns off because there's no fire. It detects no fire. And the buzzer also turns off. But the output is high. It is off, but the output is high. When the output LED on, the output is low or pulling it down to the ground, causing the current to flow into the buzzer, then to the module. That's why it turns on the buzzer. It sounds the buzzer. So that is the connection. When this is on, buzzer on. When this is off, the buzzer also off. So I chose to do this kind of configuration or to connect this buzzer this way. It is a sourcing current. The buzzer is sourcing current, then syncing to this sensor is syncing down to the ground.